1. SDRAM, the metronome, 1993. The engineering fix. Before 1993, RAM was asynchronous. The CPU would request data, and the RAM would fetch it whenever its internal circuitry allowed. Like a fast chef, shouting orders at a cook working at their own random pace. Synchronous DRAM, SDRAM, tied the memory's internal clock to the CPU's system bus. Both components started ticking to the exact same metronome, allowing the CPU to schedule calculations perfectly with zero wasted downtime. Speed, up to 1 GB per second. Maximum capacity, up to 1 GB per stick. What it let you do, this was the dawn of true multimedia. SDRAM gave PCs the memory coordination needed to run Windows 95 smoothly, play the first 3D games like Doom and Quake, and browse the early web while playing an MP3 in the background. DDR1. As CPUs got faster, simply cranking the speed of standard SDRAM caused heat and stability issues. Double data rate, DDR, engineered a way to transmit data on both the rising, signal going up, and falling, signal going down. Bandwidth doubled instantly, without extra heat. Speed, up to 3.2 GB per second. Maximum capacity, up to 1 GB per stick. What it let you do, this powered the broadband era. Everyday users could finally multitask heavily, downloading music on Napster, chatting on AOL Instant Messenger, and writing a Word document all at once. It also enabled massive, rich 3D worlds like World of Warcraft and Half-Life 2. The everyday headache, the blue screen of death. Upgrading RAM became incredibly finicky. If a user bought a new stick of RAM that was slightly faster, or a different brand than their old one, the system would often freak out. Minor voltage mismatches, or speed timing errors, resulted in the infamous Windows blue screen of death, causing random, catastrophic crashes right in the middle of whatever you were doing. DDR2, the wider highway, 2003. The engineering fix. DDR1 wasn't pushing enough data for early multi-core processors, and its high voltage generated too much heat. DDR2 bumped the background prefetch up to 4 bits. Internally, the memory cores lined up 4 bits in a parallel row and shot them out lightning fast. Crucially, it dropped the operating voltage from 2.5 volts down to 1.8 volts to combat heat. Speed, up to 8.5 GB per second. Maximum capacity, up to 4 GB per stick. What it let you do, DDR2 drove the laptop revolution. By lowering the power draw, it allowed everyday users to buy heavy desktop replacement laptops that didn't melt or die in 30 minutes. It handled the flashy, transparent graphics of Windows Vista and 7, and allowed you to actually watch early YouTube videos without the PC choking. DDR3, the 8-lane expressway, 2007. The engineering fix. Processors were getting hungrier, and turning up DDR2's clock speed caused overheating. DDR3 doubled the background trick again, bumping the prefetch up to 8 bits so it could fire them off simultaneously. It dropped the operating voltage further down to 1.5 volts, allowing much higher speeds while keeping power stable. Speed, up to 17 GB per second. Maximum capacity, up to 16 GB per stick. What it let you do, the birth of the browser tab hoarder. High capacities meant everyday users could leave 30+ tabs open, stream Netflix in 1080p HD, and Alt-tab out of massive open-world games like Skyrim or Grand Theft Auto V to check a guide online without the game crashing. DDR4, parallel processing, 2014. By 2014, grabbing massive chunks of data in the background caused internal traffic jams. Engineers split the memory architecture into 4 distinct bank groups. While the RAM pushed data out of Group A, it simultaneously prepped data in Groups B, C, and D. This parallel processing eliminated delays. Voltage dropped again to a highly efficient 1.2 volts. Speed, up to 25.6 GB per second. Maximum capacity, up to 64 GB per stick. What it let you do, the 4K and Creator era. Everyday users could now seamlessly edit 4K video shot on their iPhones, stream gameplay on Twitch at high resolutions, and keep 100+ browser tabs open spanning multiple heavy web apps, like Google Docs, Figma, or Spotify, without the PC breaking a sweat. DDR5, 2021. Modern CPUs with dozens of cores clog a single data highway. DDR5 splits the standard 64-bit data channel into two independent 32-bit channels, allowing one stick of RAM to serve two entirely different CPU requests simultaneously. It also features on-die ECC, automatically fixing microscopic data errors caused by electrical noise, and move the power management chip directly onto the RAM stick itself for incredibly clean 1.1 volts power. Speed: 38.4 GB per second to over 64 GB per second. Maximum capacity: up to 128 GB per stick. What it let you do? The AI and extreme multitasking era. DDR5 bandwidth allows everyday tech enthusiasts to run local artificial intelligence models, like generating images or running text-based AI, directly on their home computers without relying on the cloud. It allows heavy simulation games like Cyberpunk 2077 with ray tracing to run fluidly, alongside massive multi-monitor setups running 4K videos, Discord streams, and hundreds of tabs.